In 1976, two powerhouse singers came together to form a single variety show, the likes of which the music industry has never fully recovered from. Young heartthrob Donny Osmond blended his style with his sister Marie's vocal genius to form The Donny and Marie Show. The show featured musical numbers, dances, comedy skits, and of course, the famous I'm a Little Bit Country, I'm a Little Bit Rock and Roll powerhouse jam. As a young 7-year-old at the time, the Donny and Marie Show was a Friday night treat. I didn't really understand why at the time, but Marie Osmond still has a special place in my heart to this day. Which got me thinking, what if two powerhouse companies, I don't know, like one of the largest chip makers in the world and one of the largest software makers in the world, got together and formed a single unified thing? That would be epic, too. For those audience members that are listening for the first time, By Engineers for Engineers is sort of like a side conversation that you have at SKO or Explore, or usually at the bar. John and I hosted 134 shows at VMware, and today we are continuing that adventure with B4E 2.0, or B4E Plus. No, you can't use the plus word. Let's just stick with B4E. Sibling rivalries aside, John and I are able to merge our two distinct personalities together as Broadcom and VMware are merging their capabilities. And yes, we all go together like country and rock and roll. On today's re-inaugural By Engineers for Engineers, we are going to celebrate the federation of our two distinct companies with two distinct cultures, hosted by two distinct personalities with our guest, Mr. Federation himself, as he explains how it all comes together with NSX and VCF. Next on By Engineers for Engineers.
Hello and welcome to a new edition of By Engineers for Engineers, a live, no-holds-barred, unedited VMware by Broadcom podcast where we embrace all things technical. My name is Chuck Bell, VCF Solutions Architect out of Pittsburgh, Pennsylvania, and as always, joined by John Matthews, VCF Solutions Architect out of Houston, Texas. So hey, John, new year, new company, new title, same show. But I have been asking you for 8+ years now to allow me to use the Donny and Marie intro, and you finally relented. So I wrote a monologue, I got all excited, I downloaded the song, and then the show topic and the guest changed. And unfortunately, our guest did not agree with my variety show song theme choice. And if you're not aware, the guest does get to pick their walk-on song, so maybe next time I can play some of my variety show jams. Anyway, enough of that. Are you ready to kick off the By Engineers for Engineers show once again here at Broadcom?
Yeah,
of course. Great intro. Great intro. Thanks for making that.
Thanks.
There was so much inside baseball on that particular thing. That was awesome. So to answer your question, as far as the variety show jams, anyway, so yeah, I'm excited to kick this off. This is our very first B4E with Broadcom. I think it's going to be fun.
Yeah. So definitely a blend of some inside jokes there with a basic explanation of what B4E is for those who might be joining for the first time. So with all that behind us, yeah, let's kick things off.
So first, public service announcement. Chat is for banter, so you can use chat to kind of joke back and forth or whatever you want to do with. Please put your questions in the Q&A platform. We have a set of panelists that are monitoring that and will answer all your questions. They may even ask it live, depending on how what they think about it. But let's get on with the show today. We wanted to kind of answer the question of why NSX with VCF. So this is generally a little bit higher level than what we normally do, but I think it's important to kind of understand what the why is around NSX. So our guest today is a member of the VCF technical product team. Dimitri, feel free to introduce yourself and start kicking this off.
Yeah, thank you. So yeah, I'm Dimitri. I guess you will quickly find out I'm French with the accent. I've been working in network virtualization for quite a while now. since the nice era days for people on the show old enough to remember that startup. And after that, I mean, yeah, I joined VMware, now Broadcom, but still doing network virtualization. And before that, because I'm a little bit old, yes, like old network engineer, I started with appliances and physical, and yeah, I'm happy with the transition I've made to the virtual side. It was not a difficult transition, but yeah, happy to be on that side now. Okay, I think that's enough for the intro. What I want to say is, yeah, this, as John mentioned, it's a little bit high level. That said, I mean, feel free to jump in if you have any more deeper technical question. I should be able to answer it. And I also have in another screen some labs. So if your question is a little bit technical, I can always use also the lab instead of slides. I'm more a lab guy than a PPT guy. So here we go. So now let's start. By the way, this my understanding is this deck, I mean, there is nothing confidential in it, so will be shared with you at the end. Use the presentation mode because there are tons of animation, and if you don't use that mode, it will look all ugly. So yeah, just one quick tip. So yeah, that's the agenda. So we'll spend some time. I mean, we'll go shorter or longer depending on you, based on your questions. But that's the first piece, which is why NSX and VCF. I'll go straight to that point. And then I'll talk to what are the VCF use cases. So that slide here is not from me, it's from VMware by Broadcom, big marketing guys, but I'll explain, and I'm sure you've seen that slide many times already, but I'll explain which ones are possible or enabled only if you use network virtualization in your for your use case. And network virtualization means, of course, NSX. And then, I mean, this deck is usually something we use in a one-on-one conversation with a specific customer. So then we have an open discussion with a single customer. Now we'll see how we do that. But then after that, open discussion with the customer talking about his needs or projects or challenges or issues or questions on VCF and network or security related. Then I have a bunch of annex where we can drill down and explain or answer to his questions. Okay, so that will be the flow for today. And yeah, I hope that's okay. And let me jump in. Oh, by the way, my understanding is you can unmute yourself, and I love to when it's more interactive. So feel free to use that option, and if you have questions along the way. Okay, so I'm not speaking alone. Okay, so what is NSX in VCF? Before answering to that, let's be all on the same page on what is VCF. And VCF is an on-prem cloud. So it's the same thing, or the goal at least, is to give you the same thing you have in any public cloud, AWS, Microsoft, Google, I mean, the one you love. And to explain how we do it with VCF, which is actually very, very, very similar to what public clouds do, I have this on the screen. So this is the logical view, those two graphics. On the left is the logical view. So that's what the cloud user, cloud admin, believe he has. And that's the physical view. So that's really what you have in your data center or what people have in their data centers, AWS, Microsoft, Azure, whatever, Microsoft, Google, Oracle, whatever. So which is a bunch of servers racked together in multiple racks in a data center, all connected together through or between racks through top of the rack, a switch or router. Okay, and your data center, completely, I'm completely sure that's exactly the same. It's a bunch of racks with servers connected with physical fabric, switches, routers. So, okay. So what is VCF? VCF is compute virtualization, like any cloud, public, private, with VCF is compute virtualization. So here you can see a bunch of VMs. It could be containers, but I'm representing here a bunch of VMs in the logical view because that's what you believe you have. And physically, those VMs or containers are spread out among your physical servers in your different servers in your different racks. So cloud is compute virtualization. Storage virtualization, same thing in the logical view. You believe you have storage for each of your VMs or containers, and that is also spread out among these or those storage spread out among all those physical servers. Compute virtualization, storage virtualization, network virtualization. Here I'm representing in the logical view a very basic application, two-tier web tier, DB tier application connected on different subnets, routed with a single router. Logical router. And that's what you believe you have in the logical view, and that's what is physically implemented. Those network components, switching, routing, are also the same as compute and storage, fully distributed among your servers. That's important. It's inside the servers and fully distributed. Same thing, any public cloud or most public cloud, if not all, and definitely VCF offers also security. And here, so you have like a little distributed firewall, we'll call that. So a little firewall features, but not on, I mean, it could be on the logical router, but us, VCF, we can also do that on the VM VNIC or containers CIF, container interface, to protect communication that is entering to the VM or exiting the VM. And those are logically represented here in the logical view like this, or in the physical view, they are where the VMs are, so fully distributed as well. And the benefit of being virtualized and fully distributed for all those components inside the server. So technically for VCF inside the hypervisor, inside your ESX, that's great because it gives you scale. Because now there is not a single bottleneck. It's all distributed, and so great scale, more servers, more scale, and great high availability, because if you lose a server or lose a rack, you still have a bunch of servers, ESX, to fulfill those services, cloud services. So that's what is VCF. And on top of that, you have some orchestration, because I mean, you can do click, click, click all day long. But many customers, not all, but many customers, when they want to deploy an application, when they want to do something, they don't do click, 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 200 click, 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 but they like to have this orchestrated. And VCF comes with an orchestrator. And this one can use Terraform, can use any kind of scripting language, or even comes with a nice UI interface and graphical interface to help you or to make your life easier to create those blueprints. We call that blueprints of your application deployment. So it's not only network, but it's also compute, storage, networking, and networking, obviously, as you can see on the screen. And finally, it comes also, because any cloud needs to be operated, it comes also with monitoring. And here I'm showing you two screenshots where you can see monitoring of your cloud, where here it's more compute storage, and here it's more networking with the logical view of what you deployed. And here you can see what I had before, the very basic two-tier app deployment. You can visually see that, also graphically see that. So that's what is VCF. It's an on-prem cloud for your on-prem data center. And what is doing NSX in that? It's doing, obviously, the network and security component. Okay? And a little bit of orchestration monitoring. What piece? Obviously, the network and security part. NSX is involved in that. Okay, so I hope that clarifies what is VCF and what is doing NSX in it.
So
Yeah.
so I kind of think the why of VCF or the on-prem cloud is to move you more towards a self-service kind of model. Is that kind of what we're trying to get people to get to?
It's correct. I mean, that's definitely if you have this use case, VCF would be a great solution because it has all the components ready for you to do that, like build blueprints, what I was calling blueprints of application, and give the ability to end users to, without any knowledge on VCF, NSX, even vCenter, deploy their application they want from a self-service catalog. That's what use case that can be fulfilled. Now there are all, and that the like the graal, like the end goal for many customers, but not all customers go that far. And if you have more simplistic goals where you don't want to give a self-service catalog to customers, but just manage your data center in a more efficient way to yourself, I mean, the IT organization, manage, deploy, upgrade, and so on and so forth, and provide disaster recovery, simple disaster recovery to your applications, but still through the IT organization, whatever that means, IT organization. Without a self-service portal, and VCF will, I mean, any public cloud, private cloud, sorry, here, fulfill completely that use case as well. Okay. Actually, we'll talk about the use case in a minute. So just to finish on that slide, so yeah, you have a good understanding of what is VCF. So it's really, the idea is to really provide you a cloud, but this time not public, but in your house, in your data center or data centers. And what I want to highlight here is if you have all those services but networking, then you cannot claim you have a cloud. You really need what is called in the industry SDN, software defined networking. You really need that service to be able to offer a cloud in your, I mean, to have a cloud in your data center. And yes, NSX is a market leader in SDN, which is again a requirement and essential for private clouds, and it's built into VCF. So it's not a third-party component you plug, you glue, or whatever. It's included in all those components come within VCF. So you have like the full package, the full solution available. Okay, so here we should have the same understanding of what is VCF and what NSX is doing. Now, what are the use cases? So John mentioned one of VCF use cases, which is the self-service catalog. But actually, as I started to say, VCF has many use cases. Again, that slide does not come from me. This deck, I made it a little bit a while ago. But I stole that slide from the whole VCF marketing team. And yeah, service catalog is not the only one. I mean, it could be also infrastructure as code, where you want the ability to developers to be fully autonomous and deploy application as code. So compute, storage, networking, and security as well. And that's fully available. I mean, you can do click, 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 as I can show you, in a lab now. You can do on NSX. You can configure your network, you can configure your security. Okay, or you can completely orchestrate that with Terraform, with the built-in orchestrator we have in VCF, as you wish, or Python, or and so on and so forth. You have also disaster recovery. You have modernize your existing data center. It's not like you have to trash everything you have, whatever physical data center you have, whatever physical vendor you have for network, for servers, for storage, you can use that existing and making it's VCF. Of course, they are on the compute side for the ESX, as you know, there are some requirements for the servers. Now, for the network and security, actually, there is zero requirement. Any physical fabric, Cisco, Juniper, leaf and spine architecture, non-leaf and spine architecture. I mean, we love them all. And we can integrate network virtualization on top of any fabric.
So
Here we go.
sorry, and Dimitri, I just had a comment. You bring up a good point about building on top of any fabric, because you're not going to go into many environments. Many of our customers already have some of this infrastructure, or they have this infrastructure already built. So NSX can, or VCF networking can go on top of your existing fabric and almost be like a ship in the night. So you can begin to use some of these use cases you have highlighted here, in addition to the way that you've always done it, and then slowly migrate workloads into this domain. Is that correct, or do I
Yeah,
have that?
yeah. No, that's completely right. On the VCF network and security part, there are some points I can talk about it later. But yeah, it's completely decoupled from the physical fabric. And we can explain that deeper on technically how it works if you want. But yes, it's fully decoupled. So you don't need to trash and redo a new data center. You can use your existing data center and enjoy the benefits of network virtualization on top. Talking about the benefits, that's a great transition. That's what you get with network virtualization. I mean, of course, I don't know in the audience when you started. I assume most of you have some network knowledge or are actually even network engineers. And I assume all of you dealt a little bit or a lot with Cisco, Juniper, Arista, Cumulus, I mean, name it. And you know how to create a network on the physical fabric. Now, if you do it on in the logical space, I mean, all the knowledge you have remains the same. A router is a router, whatever if it's a physical router or a logical router. Routing is the same. BGP dynamic routing is the same. NAT is the same. Load balancing is the same. It's the same as compute. I like this analogy I used 10 years ago. A VM is the same as a physical server, but it's much more, it's 10 times, 100 times simpler to manage when you have a virtual machine. You can place that virtual machine anywhere. You can move, you can copy, you can snapshot. With network is the same. If you want a new physical router, I mean, you buy one, you go to your physical data center, you take your screws and your screwdriver, you put it in place. I mean, okay, it's feasible. I mean, I've done that many times. I haven't done it for more than 10 years now, but I used to do that. I mean, do it in logical space. I mean, I want to create a router. Oops, here we go. Done. I create a router. I mean, I can plug it to the physical location Paris. I can make it in Paris. I can make it even stretch in Paris and London. But yeah, at the end, I give a name. I plug it to my location Paris or Paris London, so I can choose where to put it in Paris and or London, and that's it. I mean, I can do route advertisement. Okay, advertise my subnets. I will connect to my tier one. So I have a bunch of options, but I do all of that. We can go in details on what those means, but they are very simple. It's all graphical. Of course, you can do the same with API with Terraform or other scripting language you love, and that's it. Done. You created your router. So it's much simpler. So that's one of the benefits of doing network and security virtualization. It's fully orchestratable. I don't know if that's English or not, but you can fully automate it.
Can you go back to that for 1 second? Because I just want to make sure that I grasp what you were doing. So you're creating a tier one router, and you're actually placing it in two different locations at the same time. So you're able to have that router functioning in both locations just by
Yeah,
what was
this
that?
one is a case where you have it's my lab where I have Paris and London data centers. It's not like you must have two data centers. It works also, VCF works also with one single location. But yeah, this one is a little bit more complex. I should have picked up another lab
But
where
make
yeah,
sure.
you don't have two locations, but you're correct. Yeah.
Yeah, so you can place it in just one location, you can place it in several locations, whatever you want to do, and
Mhm.
that how okay, cool.
Correct. And those is for the route advertisement. I'm sure you know that in physical world also you need to, when you create subnets or VLAN, the old ways, when you create VLAN on your physical Cisco, Juniper, Arista, whatever, you want to advertise that subnet. You can do static route, but honestly, it's yeah. In production, you most likely not have that. You can do BGP, you can do dynamic routing. So we have the same thing, except here you do it only once. I don't want to explain the concept of tier 0 and tier 1 now. It's a little bit more advanced. But when you create a router, you don't need to do that for each router. You just create it once, which I did in this one. And here you just plug that logical router to this router I created before with my BGP and all that. And I can simply, without reconfiguring dynamic routing, advertise that to the physical world. And if I have two locations, like here, I can advertise my future subnets I will have on this logical router. Here, physical, I will advertise it to Paris and London, but at a better cost in Paris because it's primary, and at a lower cost in London. So traffic will enter and exit via Paris. But if anything happens in Paris for whatever reason, fire or whatever, not too much earthquake in Paris, then automatically with no human touch on VCF, on the NSX component of VCF, nor any special configuration, any touch of the physical fabric, automatically the traffic will enter and exit via London because it's already configured as secondary. And it was advertising my subnets below this tier 1 in both locations. It was more expensive in London, but it was advertising it. So without human touch, VCF, physical fabric, people will enter via London if I lose Paris. Okay.
So Dimitri, you jumped to kind of a DR kind of scenario, but if you can go back for a second, there was a
Yeah.
question in the Q&A on why use NSX as part of the stack. And so the simplicity
Yeah.
piece that you were just talking about, can you kind of go through that a little bit on what the difference would be between VCF with NSX and VCF without NSX?
Yeah, I'll do that in 1 second. Yeah, that's a very good point. So as you can see, all those bullet points are hyperlink, and I can jump directly to those points where I have some slides explaining those. Again, we can go also directly on in my VCF lab. But yeah, so just before going there, I just want to finish the other benefits. So we talked about simplicity, and we'll go deeper into this. We talked about orchestration, full automation. I want to highlight that because many, not existing customers, but usually non-existing customers who are looking at VCF and network virtualization, and with that have been doing physical for their entire life, like all of us at the beginning. They are afraid, or they have this idea that, oh, because it's running inside my hypervisor, my ESX, then so on x86 CPU, then the performance will be bad, and I won't be able to. I can do a lab, but I cannot go into production because my throughput, my performance needs will be too much for my physical servers, my ESX servers, to add network virtualization on top of their compute virtualization. So that's completely incorrect, actually. And those bullets talk about that. It's completely incorrect because there are a ton of optimization and offload. It's not like the CPU is doing the network and the security. It's offloaded to the PNIC that can do tons of traffic. When I say tons, it's 20 gig plus. And then you can have multiple PNIC, physical NIC on ESX. So you can, and it's also fully distributed. So each ESX can do does its switching, its routing. So you have 20 gig plus per ESX. So it goes very, very high in throughput and with the power of distribution and the power of offloading it to not use the CPU. Then availability, we briefly talked about disaster recovery, but I go deeper in this, how network virtualization helps the simplifies greatly your DR use case because the network is everywhere. So the subnet, the default gateway, the security is everywhere. And that makes your life much easier when you want to recover your compute, your applications. And security, which is included as well into VCF. Okay, so yeah, I just wanted to finish that slide and then I go to your point. Not all those benefits resonate to customers, or not all customers, or actually most customers don't go with NSX for all those points, but a handful of those, and then they still enjoy the other bullet points or the other benefits. But one benefit that all customers enjoy and calls out is with network virtualization, your applications are now deployed much faster. And if you have a cloud team, you don't need a cloud team, but if you have a cloud team, it can be fully autonomous. And they don't need to open tickets to IT organization to, hey, give me a new subnet, advertise that subnet, so BGP, advertise that subnet to the world so the world can access my application on this new subnet. Please secure that application, and so on and so forth. And this translates, so this is a little bit more sales than technical. But yeah, this translates directly into CapEx and OpEx reduction. If you don't have network virtualization, then what happens? Then yeah, as I said, now people cannot be autonomous, and they open plenty of tickets, and that's a survey we did a couple of years ago now, but still fully relevant. And please unmute yourself and share how you do it also if you have the same kind of challenge. Yeah, it translates to many tickets, and so more than a month to deploy a single application. Because yeah, as I said, you need to do all of those, or maybe not all of those. Maybe people don't have advanced security in place. Maybe they don't have LB. Maybe in terms of needs for this application. But it will be just a subset of those tickets, but still plenty of tickets, dozens of tickets to get an application up and running. Okay, so as I said, usually I stop here in a one-on-one conversation with one customer to talk about what did resonate, what question did that raise, this introduction raised, and and based on that, I jump to benefits, and those are hyperlinks. So yeah, we can start with the simplicity piece. So if I go to modernize, it's a hyperlink, so you see I can click. You have all those benefits when you take your existing data center and you add VCF into it with network virtualization. And here I'm highlighting only the network piece and security piece. So yeah, I can go through all of them, but I'll go with I mean, central and simple installation. I'll go, yeah, even past this because at the end of the day, you do it once and that's it. But it's very simple because VCF is it's one solution that will deploy all the services you need. This one is a important one. Let's say I picked up on Cisco, but again, it could be anything. So why it is simpler? Because it works on any data center, network fabric. So you have your Cisco, maybe Cisco the old way, or maybe Cisco the new way with ACI. We can talk about ACI actually a little bit later if you want. And you have multiple racks. So you add network virtualization. This one is very high level. It may raise plenty of questions, and happy to go on those questions if you want to go more technical. But yeah, it's fully decoupled from the fabric, so you can deploy your logical network, and this one will be inside your ESX. And so you don't need to touch your physical fabric. You keep the same physical fabric you have. And this physical fabric doesn't need to know create VLAN or create interface or create whatever. It's completely not touched on the physical fabric for those subnets. They belong in the logical world, and that's it. Then how does the physical router Cisco talk to those subnets? Through what we call a logical router tier 0. That's what I did not show, but that's what you have here. And then they enter the logical space, and then we keep the traffic in the logical space. So long story short, there is no requirement at all on the physical fabric, and it's fully decoupled. And then, by the way, if you have another data center because of an acquisition or as a project or existing data center, then that's fine. VCF can install all its services, so compute, storage, networking, security, orchestration, monitoring, now not on this data center one, but on both data centers. Even if this data center is another physical fabric, I had Cisco in DC1, I have Arista in DC2, that's perfectly fine because we are in the logical space. It's like VMs. You may have physical servers Dell and some other physical servers HP and some other physical servers Cisco. That's fine. You run ESX on top of it, and your VMs can go on any of those. You don't care at all. It's the same for logical network. And then you can have your network that is stretched among those two locations. So this subnet is everywhere. This logical router is everywhere. So now you can use the power of vCenter, move your VMs within your data center one, or even move your VMs between your data centers 1 and 2. And since the network is everywhere, that will be perfectly fine. You can see here in this um, lab, I have my vCenter Paris, I have my vCenter London, and I have in the same subnet Web1 that is physically in Paris, in my data center Paris on this port group, on this subnet, and Web2 that is physically in London on the very same subnet, and the VMs don't know anything about that. They don't need to, and they believe they are next to each other, and that's perfectly fine. Of course, if you have latency between Paris and London, which I have, the traffic will be a little bit slower. If I go from outside and I ping my Web01, then you can see it's quite fast-ish, and it's a little bit slower when I go to London because I have more latency, obviously. But other than that, it's completely transparent, and I can move a VM from one location to another location, an ESX that is in Paris. And I can do that keeping the very same VM with the very same IP, with the very same default gateway. It will oops. Oh, I don't know why. I should. What? Oh, because I didn't select the good one. I need to select, no. Okay. That's I'm not sure why I cannot do that. I should. Okay, that's the demo effect.
You did, yeah, you did
Uh,
You get
sacrifice
the
demo
sacrifice
doc.
thing. Yeah, you're supposed to do that first.
no, I don't know. Oh, yeah, I don't know why. It's the demo effect. Like I can definitely do that normally. I'll try. I don't know what I did in my lab. But yeah, so that's the beauty of network virtualization, the same as compute virtualization.
So,
Now,
so
if I
Dimitri,
flip,
just
yeah.
just a quick question. So, I'm first off, I'm glad that my demos are not the only ones that are flawless. I just want to start off with there. So going back to automation real quick is something that actually is quite interesting. So, so from within VRA, within vRealize automation, right?
Mhm.
When someone wants to go deploy a workload, so that you have something that's repeatable, so that you're not making mistakes on it. You want to go deploy a Windows machine or Linux machine. What I saw earlier, I just want a clarification on that. You can actually take NSX objects like a NAT, right, a network address translation or a segment, and
Mhm.
deploy that with the workload. Is that indeed correct?
Yeah, the your orchestration will now be able to manage the whole application. So compute, storage, network being creation of a network or consumption, a creation of a new network or consumption of an existing network. And that network can do NAT, no NAT, can do LB, cannot do LB. And all that orchestration will talk to one single endpoint, which is your VCF. So it's completely centralized.
So that's pretty powerful then, right? I mean, because you can actually take your whole network instead of having to try to contact networking services and open a ticket and everything else. You
Yeah.
literally can just go deploy it
Yeah.
from within VRA that then does the YAML code and it does this thing.
Keep this in mind, and then I have some slide to show you in a more graphical way. I love graphics, as you can see.
Sure.
Just want to finish this. How does that work if you have a private cloud without network virtualization? So you remember before I was showing you this, and the background is bright and light and beautiful. And now I flip. So when I flip and the background is darker, that's without network virtualization. So same story, I have my Cisco. Now, if I want to do that, I can. Even with VCF, it's not like you have network virtualization, but you don't have to consume it. It's a little bit sad, but then how would that work? I mean, you have your VCF that will take care of your compute and storage, but then the network and security will be done in the physical fabric, and you will create your VLAN on your physical Cisco, Juniper, Arista, whatever, and you will create on VCF, the vCenter component, the port groups for the VLAN X, VLAN Y you created on the physical fabric. So now you have, as you can see, two solutions, or maybe three if you have your Palo Alto, your Fortinet, your security vendor you have on top of your network vendor. Then you have three vendors, three solutions, three UI, three API to manage your cloud. Or now I would not call that a cloud, I would call that your data center. And if you have another one, so you have network and security done in this data center too, maybe other vendors for network, maybe other vendors for security. So now you have maybe 4 or 5 solutions or vendors for all of that. And this network does not exist in location 2. So you cannot move a VM freely from location 1 to location 2 because you run out of resources, of compute resources in location 1, and you have plenty of resources in location 2 as a use case. Then you cannot move it anyway because the network does not exist here. And yeah, and then you lose all those benefits on top of manageability operation that is more complex because you have 4 or 5 vendors now.
So this is what I
Okay.
was getting to earlier,
Yeah.
Dimitri, and I was asking you that simplicity question, which is,
Yeah.
do you see many customers orchestrating 4 or 5 different vendors to accommodate the cloud model that you kind of outlined earlier?
Orchestrated? No, they do manually. And so that do exist. And customers do have physical fabric with multiple vendors, or even one vendor, but another vendor, or multiple vendors for security. And on top of it, compute virtualization with us, so vCenter. And you can do click on all those, or you can do some orchestration to not do click or CLI command on your Cisco, conft, and so on and so forth. But that will be, it's not a single script, a single flow, a single thing. They will do that through tickets and do one step at a time. And yeah, and we're back to, so it does work. I mean, it's not like data centers and applications did not work when VCF did not exist, but it's just, yeah, slower, more complex, error prone, and interoperability challenges. And on top of all those, what I'm talking about, I just talked about, is just also now your application is stuck into one data center. If you want to move it to another place, or one data center, or one building, or one in one location, if you want to move it because of disaster recovery, or just because your data center one or building one is full, there are too many applications in it, and location two doesn't have so many because you deployed it 6 months later or 1 year later or whatever. It doesn't have so much resources used. Still, you cannot move application, or you can move, but it's super complex to move an application from a location one to a location two when you don't have network virtualization. And this simplifies that greatly.
So we've talked about the simplification. We've talked a little bit about DR on a couple of instances. One of the things I wanted to ask you about, and you alluded to it in one of the slides, and I see it here on this slide, is the concept of a virtual private cloud, or VPC. I've seen that term
Yeah.
used in like Amazon and
Yeah.
Google. Can you talk a little bit about what we do with VCF and NSX with VPCs?
Yeah. So that's something we introduced, recently-ish, 2 releases ago. So if you know NSX, but are not using recent-ish release, you may not be aware of that enhancement we did. So the idea is, not all customers went all the way through a self-service portal where they have the cloud admin created application templates, and then the end users can manually decide to roll out this template or this application through a self-service portal. So they didn't go that far. But still, they want to give full autonomy to the end users without giving them vCenter full admin, and also, let's say VCF full admin access. So VCF full admin access means I'm full admin of vCenter, I'm full admin of the network component, I'm full admin of everything. So for the network and security component, we came up with this idea of VCF. So it will take 5 minutes, stay with me. You don't have to do it, but it's pretty powerful. And if you want to, if you have this use case, that's pretty cool. So we acknowledge that in a company, you have a big boss network or big boss security admin, and he doesn't want to lose that ownership and give to all the employees or all the developers the ability to do too much on network or too much on security. Because the employees, the developers, they have no clue about what IP address they should use. They could do IP conflict. They could take the same IP as the IT DNS server, for instance, and break everything. So they want to keep ownership on security, on network, and also security. I mean, they don't want someone to allow SSH, a developer to allow SSH from internet to their new application. So we acknowledge that. So in the NSX component of VCF, the network virtualization and security virtualization component of VCF, has this VPC concept. So what it is, the NSX admin is in charge of, obviously, the physical router, the physical fabric, your Cisco, your Juniper, and also NSX. He's the big boss, the big admin of the NSX component of VCF. And so he will create this logical router. We call it a tier 0 logical router, which is the logical router that does the communication between the physical and the logical. There is nothing in the logical space yet, but he will create, yes, this tier 0 logical router and configure BGP. So any future subnet that will pop up below the tier 0 will be advertised to the Cisco, to the physical fabric. So he's in charge of that, to create this logical router and configure BGP between the physical and this tier 0 logical router. Then he will define block of IP addresses that will be available for that cloud for future applications. So here's just a list of subnets, one or multiple subnets that will be available for future applications in this cloud. And he will also define the protocols, so the security that is allowed for the north-south communication for the future. There is nothing for now, but for the future application that will be deployed here, that's the NSX admin, the big boss network and security admin, will be in charge to say what is allowed, what is not allowed for north-south communication, as well as east-west within an application. There is no application yet, but within an future application, what will be allowed for this application to talk within itself.
Extra like shared resources, stuff like that. He manages all the firewall security profiles for shared resources, inter communications, that kind of thing, right?
Yeah, exactly. So for the north-south communication, for instance, it will say that any future application will be able to do NTP communication to my NTP servers, DNS to my DNS servers that are physically somewhere in my data center. Exactly. Or to download patches from Ubuntu, Microsoft. The VMs will be, the future applications will be able to download that from outside of the world to inside of the world, to the logical space. So he's in charge of this. So that's the first persona. Then you have the second persona, which is the project admin. And this one will be the marketing manager, the finance manager, whatever. And he will create a VPC. So I'm sure you know VPC in AWS. So that's the same concept. You buy a VPC. Here you create, this persona will create a VPC. So what does that mean when you create a VPC? It doesn't really know that. It doesn't really see that. But when you create a VPC, actually there is a logical router that will be created internally, a tier 1 logical router. So a logical router that will be plugged to that tier 0 north-south logical router. And that's it. So that's what a VPC is. You have for this VPC a logical router that gives you access to that is plugged to a logical router that gets access to the physical world. And it will associate VPC users like AWS. You can add VPC users to your VPC in AWS. Same thing here. The project admin can say, hey, this developer 1, this developer 2, this developer 3 has access to that VPC. And then the third persona, this VPC admin, can create network. And here it does not choose what subnet to use for those networks. It will just say, hey, I need a subnet, or I need 2 subnets because I have a 2-tier web tier, DB tier application. So I need 2 subnets. I need those subnets to be so big. I need so many IPs. And that's it. Who will take the decision of what subnet, what IP to use? It's automatically NSX that will pick up subnets based on what the big boss network admin gave in terms of IP available for VPCs, for future VPCs and future applications. So the VPC admin is fully autonomous to decide how many subnets you want. You can create quota, obviously, because you don't want the VPC admin to burn billions of IP addresses. So you have quotas you can set up. But yeah, the VPC admin is fully autonomous to say, I need 1 subnet, 2 subnets, 3 subnets, that big. And then the VPC admin will deploy its application. It's VM, web, it's VMDB, plug them here. So it has been fully autonomous without opening any IT ticket And same thing for the network. You can say, hey, I want to allow only MySQL from web to DB internally, and only HTTPS from outside to inside. So it can restrict or protect and restrict the communication to its application and between members of its application. Of course, if he says, I want to allow SSH from outside to my VMs, but the big boss security admin here did not allow SSH, of course, who cares? SSH won't be possible. What the VPC admin can do in terms of security is just restrict protocols from those already allowed by the big boss security admin. So if I wrap up with this concept, it's not like you must use it, but it's very, very convenient if you want to use it to give to your developers full autonomy. Then yes, you can do that with VPC, keeping full ownership of network and security if you're the big network and security boss.
So outside of the native public clouds, Dimitri, of course, we know Amazon and Google use the concept of VPC, and Azure uses the concept of a VNet. These are all equivalent. Any other SDNs other than us that have the ability to do a
I'm not aware.
private
For private clouds, I'm not aware. What you do is this. That's what I'm aware. That's what people do.
Yeah, it kind of goes back to that simplicity comment from earlier, for sure.
Yeah. So I didn't notice it's already almost the top of the hour.
Yeah.
So there are much more. I just want to do one more if you give me, because that's a question. I don't know if people raised that question or not. I didn't follow the Q&A. But that's a question I had a lot, and I just want 1 minute on this.
Sure.
I didn't go too technical here on how we do the full decoupling. That's why we work on any Cisco, Cisco, Juniper, whatever. We do overlay. And physical fabric do support overlay as well. You can do VXLAN on a Cisco, on a Juniper, on an Arista. So what is the benefit to do overlay in VCF versus doing an overlay in the physical fabric? Or if you already have overlay in the physical fabric, that's perfect. I mean, that's perfectly fine. But what is the benefit of doing an overlay, a second overlay with us? A second, logical network inside VCF when you have already something in the physical fabric. So I'll go. There are many reasons. I'll just use this one because that's a key point. All the others are also important, but this one is the root, the main reason, or the top reason why. So if you have network virtualization with us, so you have a single point of configuration for your compute. That's the vCenter component of VCF I'm showing. I'm sure you know this very well. That's the NSX component of VCF I'm showing here. So you have VCF for all your services. So if you want to deploy a new application, you go first, you deploy your network. It's always like that. Nothing to do with VCF or NSX. You always start with network. So you go on VCF, the network component, and you create your router, your subnet, your segments. We call that segments, but your subnet. And then you create on VCF again, the vCenter component. You create your VMs, could be containers. And then maybe if you want security, you also go on VCF and you configure your security. Okay, done. So from a single point of configuration, VCF, you created your whole application: compute, storage, network, security. If I don't have network virtualization with VCF, how do I do it? So I start with network. So I go on my Cisco, my Arista, my whatever. Maybe I configure VLAN, maybe I configure VXLAN. If you have Cisco ACI, that's perfect. You can do VXLAN also. So VXLAN or VLAN. So you do click, 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 or you do API on your Cisco, your Arista to create that VLAN, VXLAN. But then you also need to do click, click, or API on VCF, on the vCenter component to create the port groups. So you touch two endpoints just for the network.
Two
Yeah.
networking endpoints, which I think is key.
Two network
well.
endpoints. Yeah.
Yeah.
Two network and two endpoints for the network. Yeah.
Exactly.
And then, okay, you deploy your compute, your storage. So you do click, click, click on VCF or API on VCF. Okay, fine. And then you do wants to secure this, then you do click, click, click or API on your security component. So you go on Cisco or Juniper or Arista. On your top of the rack, you have very basic ACL and nothing like IDS, IPS, or anti-malware. So most likely you have a Palo Alto or Fortinet or something. So a third vendor solution to do your security. So here you touch three solutions, 3 points just to do this. And if you have two locations, of course, that doesn't make this possible because your network won't be in the location 2, will be only in the location 1, but I don't want to bring this up. But so conclusion, even if you have Cisco ACI, which is good. I mean, it's not like I believe it's a bad solution. You can keep your Cisco ACI, and that's great because now your ESX IPs, not the logical networks inside, but your ESX IPs are in two physical racks, but they can be thanks to Cisco ACI or your Juniper overlay in the very same subnet. Okay, that's perfect. But still, it's much, much better to have your applications running in our logical network. So we have overlay. We don't use VXLAN, we use Geneve, but that's details, technical details. At the end, it's an overlay. It's much greater for you in terms of simplicity, in terms of many, many things, management, operation, to have this network, also logical network in VCF for your applications. Here we go.
Perfect. Thank you. Yeah, like you said, we just scratched the surface. This is a fantastic demonstration deck, if you will, with the animations, and we'll get this out to folks that have joined the call if they would like to explore this. We may have you on as a second show if you're willing to kind of go through part 2, because there's a lot more to touch on. But John, any thoughts before we begin to wrap it up here?
Great. It seems like we just kind of scratched the surface on this, but I think got the primary points across on what we're trying to get done with NSX inside of VCF. Why you actually need to use it.
Yeah, and the benefits you get out of it. And yeah, feel free if you have more questions, technical questions. Again, we just scratch the surface on the technical side, or if we even didn't touch it, I would say. It was more a high-level presentation of the benefits. If you want to talk on other benefits, use cases, or more technical, yeah, feel free to reach out to your local teams, or I'm happy to join as well. But the knowledge is well spread out. It's not new technology. That's something that has been there for years and years. So knowledge is definitely there, whatever if it's within Broadcom or through partners. But yeah, would love to hear back from you and follow up on one-on-one.
Great. Well, thanks a lot, Dimitri. And we are going to close out the show today. But join us next time. I think we're going to be starting this up in a month.
Thank you.
Day. And if like Dimitri said, if you have any questions, let us know or reach out to your local team.
Thank you very much. Bye.
Come.